In a recent discovery at the world-famous State Technical University of Pittsburgh in Du Bois, it has been conclusively shown that the import of Mexican citrus products has dramatically reduced major vehicle fatalities. Scientists are proposing massively increasing imports of Mexican lemons and oranges, possibly buying out whole crops, which may eliminate motor vehicle deaths altogether. The mechanism by which the lemons affect traffic patterns are not yet clear, but scientists are currently conducting research strapping chimpanzees onto motorbikes with bags of oranges tied to the handlebars. Now this is real data. As you can clearly see, traffic fatality rates have dropped and Mexican lemon imports have increased at the same time. The R-squared, or coefficient of determination, is quite high, suggesting that there's a strong correlation. But why is this such a silly conclusion? It's because of a classic logical fallacy, expressed in Latin as cum hoc ergo propter hoc, or correlation implies causation. Just because two factors are linked in some way, for example, occurring one after the other, or in the same population, does not necessarily mean one causes the other. In the case, for example, here, lemon imports have been increasing probably due to economic factors, and highway fatality rates have been going down probably due to technological improvements in the same time period. So we have correlation, but not causation. That's not to say that we can't determine causation from correlation, in the same sense that we could build a powerful case on circumstantial evidence alone, but it requires more evidence to prove actual causation. For example, we need a good mechanism, and we need a model with predictive power. Some people still find this all a bit confusing. It's not the kind of thing we often worry about in our everyday lives, but scientists have to be very careful with these kinds of statements. We use associated with instead of causes. Two factors are related instead of one being the result of the other. I don't mean to be a correlation snob. There are cases when we don't have good causal relationships, but strong correlation data, and we have to make some choices on that basis alone. I think this is probably the case in global warming. The models are not yet sufficient to determine the causative agent or agents in global warming, but we have produced some compelling correlative data, and it seems we must make some choices on the merit of the correlations alone. I'll save that for another day. The topic of this video is autism and vaccines. I'll start out by admitting a certain amount of bias on this issue. As a scientist with a background in virology, I'm a strong advocate of vaccination. It's the lowest cost, highest effectiveness, most portable, dispersible, and long-term solution to most of the world's diseases, and especially to the viral pathogens. Those who advocate ending vaccination programs have no idea how much protection from death and disease we derive from this medical miracle. Probably 1 person in 5 would not be alive today if not for vaccination. And let me put one myth to bed right away. Good hygiene is no substitute for active immunity, as any immunocompromised person will tell you. Vaccines are a way of educating the immune system about a pathogen, and more specifically about the parts that are most important for infection and disease. Some vaccines are chopped up bits of pathogen, some are whole pathogens but seriously weakened or broken. Special chemicals called adjuvants are also added to make sure that the immune system responds correctly and fully. Examples of adjuvants include aluminum salts, bacterial cell wall components, and naked DNA. After the vaccine, your immune system will contain specialized cells, ready to produce effective antibodies to neutralize the disease-causing agent. This takes away the power of the infectious agent to send out decoys, or evade the immune system, or to profit from the production of antibodies that actually accelerate infection and disease. Over time, vaccines even exert evolutionary pressure on pathogens to become tolerized, less dangerous. Fast-acting pathogens succeed better if they allow their host a longer, healthy period so that the host has a greater chance of coming into contact with an unvaccinated person and therefore being spread. Evolution is important in understanding vaccination strategies. There are also some indirect benefits to vaccination. Herd immunity. If only 5% of the population is unvaccinated, and they are evenly dispersed throughout the population, most diseases will never get transmitted, and so tend to die out. This is a benefit that those susceptible 5% derive from the largely resistant herd. Cross-protection. Vaccination against the hemagglutinin of viral influenza may also protect you somewhat against hemagglutinin of a different virus or bacteria. Yellow fever, for example. Immunological priming. Vaccines keep the immune system focused on strong antigens, those that cause a very specific antibody response. The term we use is high affinity. That can reduce the production of very weak, low affinity antibodies, those that tend to stick to just about everything, causing some mild immune damage in our body. This is only a threat for people who live very aseptic lives, but that includes a lot of the people watching this video. Now, I opened with an example of correlation versus causation. What about the effectiveness of vaccines? Have we seen strong correlations between vaccination status and disease status? Well, prior to the pertussis vaccine, the number of infected in the U.S. was about 200 per 100,000 persons. Assuming the current 300 million people in the U.S., that would be the modern equivalent of 600,000 children every year with a potentially lethal or debilitating disease. After the vaccine was introduced in 1946, deaths fell to less than 1 per 100,000 persons, reaching a historic low of 1,100 cases nationwide in 1976. So who is still getting pertussis? Well, the only high risk factors are being a child under 3 years old and not being vaccinated, with an unvaccinated person 23 times more likely to develop the disease. We use an index called attributable risk to determine the amount of risk that can be, well, attributed to a risk factor. The attributable risk for non-vaccination is 99.5%. This takes us well beyond correlation and into the realm of causation for 3 reasons. 1. We know the mechanism by which this can occur. 2. We can predict in advance which patients are statistically more likely to develop the illness. 3. The results are reproducible when confounding factors like income, education, and nutrition have been carefully removed. What about the health risks of vaccines? Pertussis vaccine, or really the DPT vaccine, which is a mixture of diphtheria, pertussis, and tetanus, was the first in the modern age to be attacked for causing health damage. And the pattern for how these attacks were to occur was set in 1975, when a class action lawsuit was launched against several vaccine manufacturers for children who developed permanent brain injuries as a result of immune responses to the whole cell pertussis vaccine. According to one British study, the rate of injury was estimated to be 1 in 140,000 doses, or 0.0007%. The excess attributable risk for vaccination was calculated to be 0 to 10 per million, or, forgive me for this, 0.0000001%. That's not even a strong correlation, let alone a causation. This was not, of course, how the case was presented to the public. The media fueled a panic. Scientific papers were taken out of context, bad studies were pointed to as definitive proof, and further testing, which showed that the DPT vaccine was as safe as saline injections, were ignored. The rumor mills, the hypersensitivity, and the lawsuits were fully in operation. Now, I just want to say, before any of you decline the DPT vaccine for your children, that some of the consequences of these lawsuits were the creation of the Vaccine Injury Compensation Plan, the closure of all but one manufacturer of DTP, the end of the live cell version of the vaccine in the U.S., which was replaced by a version not made from live cells, the so-called acellular vaccine. The cost of the vaccine increased dramatically. The whole cell version is still actively used in parts of the world that cannot afford to worry about an unproven risk of brain damage that is less than half the risk of being struck by lightning in any given year.